Hi guys. So we've been looking at trigonometry and we have looked at the sine, cosine, and tangent values of our special angles. But what if we need a sine or a cosine or a tangent of an angle that is not one of our special angles? Sometimes there are angles that we can find the exact value of by using something called a reference angle. So when we are trying to find trig values of angles that are not in quadrant 1, we need to find a reference angle. Okay, so a reference angle is formed by dropping a perpendicular from the terminal side of a standard position angle to the x-axis. Now, what I like to remind myself for a reference angle is that it is the shortest distance to the x-axis. And it's always to the x-axis, okay? And it's the shortest. Also, it's always positive because it's a distance. Distance is always positive, so reference angles are always positive. So another thing to say is a reference angle is the angle between the terminal side and the x-axis. Now there's something here called the bow tie, and this is just a little picture. Because if your angle is in the first quadrant here, the reference angle would be here. If your angle comes all the way around to here, and you're in a second quadrant angle, so that was our reference angle. Now our reference angle is here. If our angle takes us all the way to here into the third quadrant, our reference angle is here, the distance to the x-axis again. And if our angle rotates even further into the fourth quadrant, the quickest way to the x-axis is here. And again, all four of those reference angles are in what we call the bow tie, because it looks like a bow tie. Okay, so let's look at 4 different examples. Let's suppose we have an angle in standard position, so it starts here, and it's in the first quadrant. Okay, so here's our angle there. Okay, now the quickest way to get to the x-axis is here. There's our reference angle. It turns out that when you're in the first quadrant, the angle is its own reference angle. Okay, so for instance, let's say we have an angle of 45 degrees. So we rotated 45 degrees in this direction. Well, the quickest path back to the x-axis is that same angle, 45 degrees, and that's our reference angle. First quadrant is the easy one. Okay. Now let's look at the second quadrant. So we have an angle in standard position, so it starts here, but we're going to rotate into the second quadrant. Okay, so there's our angle theta. Now, the quickest way to the x-axis is here. This is our reference angle. Now notice, we went past 0 degrees, we went past 90 degrees, we're almost at 180 degrees. So this reference angle is 180 degrees minus how far you've already gone. So it's 180 degrees minus the angle. That'll tell us how far from the x-axis we are, because 180 degrees is at the x-axis. So let's try an example. So we have 150 degrees. So we rotated 150 degrees in the positive direction, and we know that this is 180 degrees. How far do we have to go to get there? Well, we would do 180 degrees minus 150 degrees, and our reference angle is 30 degrees. That's it. Now let's take a look at the third quadrant. So the third quadrant, we have an angle that starts in standard position, but it rotates all the way past 180 degrees. So we went past 180 degrees, and our reference angle is still this distance to the x-axis, never to the y-axis, always to the x-axis. Now our angle is bigger than 180, so this time it's the angle minus 180 degrees to give us the reference angle. For instance, sometimes it's easier with numbers. If we have an angle of 225 degrees, and we know the x-axis is 180 degrees, how far back do we have to go to get to the x-axis? Well, we take our angle 225 degrees minus 180 degrees, tells us we are 45 degrees past the x-axis, and that's our reference angle. One more, fourth quadrant. Okay, so for the fourth quadrant, here's our angle starting in standard position, and we rotate all the way around here. Okay, now this time the shortest way to the x-axis is over here, where it's 360 degrees. So this time it's how close are we to going all the way around 360 degrees. So it's 360 degrees minus our given angle that we rotated. So for instance, if we have an angle of 345 degrees, ooh, we went a lot. Okay, now 360 would be all the way around. How far apart? How close are we to that x-axis? Well, we didn't quite go 360 degrees, so if we subtract 345 degrees, we will get 15 degrees, which is our reference angle. Okay, guys, I'll see you in class. Have a good one.